Welcome to the Algebra Alcove with your host, Mr. Pemberton. Episode 1, Systems of Equations, Graphing Method. In this first video, we look at how to solve any system of equations by graphing. We have two equations. Notice both equations are solved for y, which means they are already in their y equals mx plus b format. As we know from linear functions, the number here, the constant term, represents the y-intercept of the graph, and the number in front of the x represents the slope, known as rise over run. So to graph the first equation, we start with the number -4 on the y-axis. Here's -4. If each one of these marks represents one unit, -4 on the y-axis starts here. So that's my starting point. To graph additional points on this line, I use the slope. My slope is 5/4, which means for every 5 that I rise, I run to the right 4. On my graph, from this point here, if I rise 5, 1, 2, 3, 4, 5, and run 4, 1, 2, 3, 4, I get this point here. If I were to repeat that process, I would get another point further along the graph. In this case, it happens to go off of my gridded area. So with just these 2 points, I can go ahead and connect the dots, creating this first line. The second equation is y equals -1/2 x plus 3. Starting with the y-intercept of plus 3, on my x and y axis, I go up to 3 on the y-axis, and I put a point. To find additional points on this line, my slope is -1/2. Taking the negative sign with the top, that means my rise is -1, my run is 2. With a -1 rise, that means I'm going to go down 1 and to the right 2, and I put a point. If I repeat down 1 and to the right 2, notice this point lands on the other line as well. Down 1 to the right 2. So notice I get several points that I can connect. You can always get additional points by reversing the process and going backwards. Instead of a slope that's down 1 and to the right 2, reversing the process, I can go up 1 and backwards 2 to get additional points on the line. Where the two lines intersect each other is the solution to this system of equations. The point x is 4, y is 1 is the solution to this system of equations. Here is another problem to solve by graphing. If you notice, the top equation is in our y equals mxb plus b format, but the second equation is not. And so we need to take this second equation and solve it for y to get the y by itself. By taking this equation, I'm going to move the 4x by subtracting 4x from both sides of the equation. That cancels these, leaving 2y. Over here, the -2 and the -4x cannot be combined together because one is a variable and one is a constant term. Therefore, we must write it as -4x minus 2. Because we're solving for y, I must get rid of the 2 that's being multiplied by y by taking the inverse, which is dividing by 2. When you divide by 2, you divide everything by 2. When I do that, I'm left with y equals -4 divided by 2 is -2x. -2 divided by 2 is -1. Therefore, my second equation can be written as y equals -2x minus 1. I have done that by taking the top equation and leaving it the same. But that second equation, we have now written it in y equals mx plus b format. From here, we can graph the two equations. The y-intercept is 2. So looking at the red line, a y-intercept of 2 starts here at 2. My slope for the top equation is -1/2, so -1 is the rise, 2 is the run. So for every 1 unit I go down, I go 2 to the right, and I put a point. I go down 1 and 2 to the right, put a point. Down 1 and 2 to the right, and so I have several points along the line. I can also go backwards instead of coming down 1 and to the right 2. I can reverse the process and go up 1 and back to the left 2. I get a point. Up 1 and back to the left 2. I get a point. And so that allows me to draw a line that stretches across the entire span of my graph. The second equation is y equals -2x minus 1. Starting with the y-intercept of -1, I plot -1 on the y-axis. Since my slope is -2, as a fraction I can think of this as -2 over 1. So for every 2 units you go down, we go 1 to the right. So from this point here, I go down 2 and to the right 1, put a point. Down 2 to the right 1, put a point. That gives me a few points on the line. However, since the equations are going to cross further back, I should get some points going backwards. Instead of coming down 2 and to the right 1, I can reverse the process and go up 2 and back 1. Go up 2 and back 1. Notice we land on a point that's on the red line. Up 2 and back 1. And so now we have multiple points on the line that we can connect. And we can clearly see where both the two lines intersect each other. They both land on the point -2, 3, the solution to the original set of equations, y equals -1/2x plus 2, and 4x plus 2y equals -2. This has been an episode of the Algebra Alcove with your host, Mr. Pemberton. Episode 1, Systems of Equations. Graphing method. In this video, you saw how to graph two equations on the same grid to determine where they intersect, which represents the solution to the system of equations. Thank you for watching.